Hello, welcome to math class. As you know, I'm going to be out for the next couple weeks, so in the meantime we're going to be watching these videos in order to figure out exactly how to do all the things that I would normally have taught you if I was able to be around. What we're going to talk about today are radicals, and more importantly simplifying radicals. So before we can do that, we really need to understand what they are. So I want you to think for a second of our rules for solving equations. So we want to use PEMDAS backwards. We want to do the opposite operation. Whatever you do to one side, you do to the other. Think about that middle rule, opposite operation. If you wanted to get rid of addition, you would subtract it to get rid of it. If you wanted to get rid of multiplication, you would divide it to get rid of it. If you are squaring something, if you had something squared, like x squared, and you wanted to figure out what x was, the way you would do that is you would find the square root. That's what a radical is. It's a square root. You'll hear those terms interchangeably. They mean the same thing. So what we're going to talk about today is how to simplify square roots. And it comes down to a couple rules. The first of which is what exactly we can do to simplify to form whole numbers. So we understand this, that if we multiply anything by itself, it's going to be that number squared. So x times x is x squared. If you took the square root of both sides, you would find that the square root of x times the square root of x is the square root of x squared. As we just talked about, opposite operations, taking the square root and squaring something will cancel each other out. So the square root and squaring will cancel each other out, leaving us just with x. So the square root of anything times itself is going to equal the whole number value. So what this means is something like the square root of 3 times the square root of 3 will equal the whole number value of 3. So that's what the square root of 3 represents. It's a shortcut for writing a decimal. So think about this. If you think about square numbers, you'll have 1, you'll have 4, you'll have 9, you'll have 16, and it keeps going. If you wanted to find the square root of 16, what number times itself equals 16 would be 4. What number times itself equals 25? You'd get 5. But what happens if somebody asks you what number times itself equals 20? Well, it's not 4, it's not 5, it's somewhere in between, and we're going to find it's not 4.5, it's going to be some decimal that's going to go on forever. So instead of writing that decimal over and over again, what we do instead is we write it as a radical, and we write it in its simplest form so that everybody knows what it means as far as its relative size goes. So that's what we're working on doing, and that's what we're currently writing, and that's what we're going to be writing. So the whole idea here is that a radical times itself will equal the whole number version of itself, because that's what this represents. It's a shortcut for that decimal that would make this work. So that's the first rule we need to know, is that any radical times itself will equal the whole number. It's like the radical sign disappears. When we multiply radicals, it's going to follow the same rules as multiplying regular numbers or integers. So, for instance, you know 3 times 5 equals 15. If we have two radicals that aren't the same like these are, okay, so if we had radical 3 times radical 5, they're going to multiply to equal radical 15. Okay, so it'll work the same way whole number values do. What we're going to do is essentially division. We're going to break apart a radical so that we can simplify it as best we can. So here's the process. What you're going to do is you're going to make a tree of all the factors of 80. So what we're going to do is we're just going to ask ourselves, what two numbers multiply to equal 80? And you could pick any two numbers. So you could pick 2 and 40 if you wanted to, or 4 and 20, or 8 and 10, and so on. It's up to you which ones you go with. If I went with 8 and 10, this is what we would get. We would get the square root of 8, and we would get the square root of 10 multiplies to equal the square root of 80. Now we want to break down the 8 and the 10. So are there any two numbers that multiply to equal 8 other than 1 and 8? Well, we can come up with 2 and 4. That'll work. And same thing with 10. We can come up with 2 and 5. So you don't want to forget the square root symbol, and the reason is a lot of people who have trouble with it, it's because they forget the square root symbol. And you're going to have to tell apart square roots and whole numbers, and you'll see that in a minute. But that's the part that tends to screw people up. So make sure you write those square root signs above those numbers, or you will get confused along the way. Next, we see if we can break down 2. We can't. The only numbers that work are 1 and 2. All right, we don't want to use 1 at all because it's not going to help us. We'll just keep doing it forever if we do that. So 2 we can't do. We can't do this 2 either. Can't do 5. It's because they're prime numbers. 4 is not a prime number. We could do 2 times 2 to get 4. So now I'm done with this tree. You'll notice all the numbers I'm left with. I was left with a radical 2. I was left with a radical 2, a radical 2, a radical 2, and a radical 5. And now what I'm going to do is I'm going to pair up these numbers because I know a radical times itself equals a whole number. So you're pairing it up. It's like you're playing Go Fish, or you're folding laundry and you're pairing up socks. It's the same idea. You just want to pair up anything that's the same. So these 2's, these radical 2's are the same. A radical 2 times itself will equal a whole 2. Same thing here. A radical 2 times itself will equal a whole 2. And then I also have a radical 5 left over. So when I'm done, I have 2 times 2 times radical 5. Our final step, after we've factored it out and after we've paired up any radicals that are the same, is we want to multiply the whole numbers together. We want to multiply the radicals together, and then we'll write it as a whole number and a radical, and that'll be our answer. So 2 times 2 is 4. I don't have any other radicals to multiply the radical 5 with, so our answer here is 4 radical 5. And that's it. And our answer is going to be 4 radical 5. That's what radical 80 equals. Got a couple more examples over here. You'll have some you can work on afterwards, but just so you can see, square root of 75 is the next one we'll do. So you could do 3 and 25 if you wanted to. You could have done 5 and 15. That would have worked as well. The 3 we can't break apart anymore. The 25 we can. It'll work to 5 and 5. And we can't do anything with the 5's. So when we're done, those are the numbers we're left with. 3, 5, and 5. The square root of 3, the square root of 5, and the square root of 5. We want to pair up the ones that are the same. It's going to give us a 5. We have a radical 3 left over. That's our answer. That's all we want to do. So again, you're breaking this down into the smallest possible bits you can. Then you're pairing up the bits that you can stick together and make whole numbers. And then you write it as simple as you can. And that's all. So the next problem, square root of 120. Whenever it ends in 0, I like to pull out a 10. That's just me. You can use whatever number you want, though. So we're going to have 12 times 10. 10, of course, we broke down earlier. You saw it was the square root of 2 and the square root of 5. 12, you can break down 6 and 2, or 4 and 3. If we did that, this is what it would look like. And then the square root of 4, we would break down into the square root of 2 times the square root of 2. All right? You'll notice square numbers you can break down like that, and you'll notice the radical 2 times radical 2 will cancel out and become a 2. You could recognize that radical 4 will just equal 2 and pull it out that way. It'll save you a little bit of time. It might be a little more confusing though, so it's up to you whether you want to do it that way or not. But it is a little quicker. Anyway, back to this. So we paired up the radical 2's to get a 2. We've got a radical 3, a radical 2, and a radical 5 left over. Can't do anything with them. So that's what we're left with. 2 times radical 3, radical 2, and radical 5. Well, the final step, again, we multiply whole numbers together, we multiply radicals together. In this case, there's only one whole number, so that's what we're going to have. We multiply the radicals together. 3 times 2 is 6, times 5 is 30. So we're going to get 2 radical 30, and that's going to be our answer. So that's all we have to do for the square root of 120. That's what our answer will be. The final 2 that I'm going to show you today, you'll notice, has a coefficient. It's going to have a number in front of it. What I am going to ask you to do is to break down the radical like that's not there, and then at the very end, multiply the whole number in front by whatever the coefficient was. So, square root of 60. We're going to break down 6 and 10. 6 breaks down to 2 and 3. 10 breaks down to 2 and 5. You'll notice the square root of 2 and the square root of 2 will become a whole 2. Radical 3 and radical 5 are left behind. They'll multiply together to get radical 15. So the square root of 60 is going to be 2 radical 15. And of course, we're multiplying it by 4. So we're going to have 4 times 2 radical 15. So when we multiply those together, we're going to get 8 radical 15. And that's going to be our answer there. So that's all you have to do. So it's the same process as before, it's just you've got this number in front, you're going to multiply by that number in front. Final one I'm going to show you is 6 times the square root of 72. So 72, you're just going to break down. We could do 6 and 12. 6 breaks down to 2 and 3. 12 breaks down to 3 and 4. 4 breaks down to 2 and 2. So what we're left with is radical 2, radical 3, radical 3, radical 2, radical 2. We're going to pair up the radical 2's together to get a 2. We're going to pair up the radical 3's together to get a 3. There's a radical 2 left over. So we're going to get 6 radical 2. That's going to be what the square root of 72 is. The final thing we're going to do is we're going to multiply the 6 that's in front there by the 6 that we had at the very beginning. So 6 times 6 is 36. So our answer here is going to be 36 radical 2. And that's all you have to do. So that's it as far as the basics. There's one more type of problem I'm going to show you, and it has to do with variables. And it's going to seem very difficult, but I can assure you it's not that bad. So what I'm going to do is I'm going to erase these first 3 problems, and I'm going to put up 2 problems that have variables. So here's the first problem we'll do. We'll do 24 x squared y to the 3rd. Now it seems like that's a pain to do. It's really not that bad. What I want you to do, focus on the 24 first, break it down the way you know how. So if we break down the 24, what you're going to notice is you'll get 6 and 4. The 6 breaks down to a 3 and a 2. The 4 breaks down to a 2 and a 2. Those are the numbers we're going to have. We can pair up a 2. We'll get a 2, and then we'll have radical 3 times radical 2 is radical 6. We would get 2 radical 6 for that part. Now what I want you to do is I want you to focus on the x's and the y's, and I want you to think about what we know about exponents. X squared, another way of writing that would be x times x, right? And y to the 3rd would be like writing y times y times y. So what I want you to do, and you don't need to write it out like this every time, but it's a nice visual to help you out. I want you to imagine that we have the square root of x times the square root of x here. And I want you to imagine, instead of pulling out pairs, that we have the square root of y times the square root of y times the square root of y. So we have however many our exponent's going to tell us that we have. Now all you have to do is pair them up. So when you do that, radical x times radical x will get a whole number x. Radical y times radical y is a whole y, and then we have a radical y left over. So when we do that, we want to multiply the whole values together. 2 times x times y is 2xy. Radical 6 times radical y is radical 6y. So that's how we would do it if we were going to break it down in a factor tree. But here's all you have to do with the variables. Take a look at the exponent. We're taking the square root. Divide this number by 2. However many whole numbers you're able to fit into it, that goes on the outside. However many whole numbers are left over, that goes on the inside. And that's it. So I'm going to show you another example where the variables are a little larger. So it's kind of hard to do with a factor tree, and you'll see exactly what I mean. So why don't we do 8x to the 7th, y to the 8th, z to the 15th. So that's what we're going to break down. That seems like a pain, but it's not that bad. Again, we focus on the 8. We break that down. We get 4 and 2. The 4 breaks down to 2 and 2. So when we're done, we're left with radical 2, radical 2, radical 2. These pair up. They become a 2. We have a radical 2 left over. So that's the numeric part of this. Now we're going to focus on the variables. So what's 7 divided by 2? How many times can we fit 2 into 7? It's going to go in 3 whole times. So we're going to have an x to the 3rd, and we're going to have 1 x left over. So we're going to have the square root of x. Over here, y to the 8th. How many times does 2 go into 8? It goes in exactly 4 times. So we're going to get y to the 4th. And then over here, z to the 15th. How many times will 2 go into 15? It'll go in 7 times, so we're going to get z to the 7th, and then we're going to have a z left over, right? Because 2 times 7 is 14. We have another z left over, so we have the square root of z. Now we want to multiply our whole numbers together, or our whole values. So we're going to have 2, x to the 3rd, y to the 4th, z to the 7th. And then in the radical sign, we'll have radical 2xz. And that's all we have to do. So it looks more difficult than it is. It's actually pretty easy to do. If you feel like you're still getting stuck, watch this video again, maybe just that last part, but that's all there is to it. So you guys are going to practice simplifying radicals. I'm sure some of you get it more than others. Bounce around, help each other out. I'll be around after school if you need me at some point. Hopefully I've popped in already, let you know when. So until then, I'll see you next time.